Hey guys, Mr. T here. This is another video. This one is on reflecting graphs of functions. So this is the last transformation we need to worry about that can be applied to graphs of functions. Unfortunately, we continue quadratics after this. It never ends. Okay. So a reflection happens when you apply a negative coefficient. So applying a negative coefficient means multiplying it by -1. If you do that to the value of a function, or if you apply the negative coefficient to the variable in a function. So if you do y is equal to negative the function of x, then it actually gets reflected in the x-axis. If you do the function of negative x, it gets reflected in the y-axis. So we're going to look at both these types of reflections. So firstly, reflecting in the x-axis, if you apply the negative coefficient to the function itself, so y is equal to negative the function of x, this causes the graph of the original graph y is equal to f of x to be reflected in the x-axis. So essentially what happens is the y coordinates of all of the points on the original graph y is equal to f of x are multiplied by -1, so they become negative. So in the example here, we're going to use the example we've been using the whole time. The function of x is x squared, so the function is squaring whatever the input is. So if I was to graph that, that's down below in blue. It's that curve that you've been seeing before. What would y is equal to negative f of x be? So all that's going to happen, and I'm going to draw that in red, is that the y coordinates of all these points will be negative. So the y coordinate of the first point at 0 is still going to be 0. -0 is still 0. Here, the y coordinate is 1. Here, the y coordinate is 1. So for the graph of y is equal to negative the function of x, is going to be -1. Here it was 4, here it was 4, so it's going to be -4 and -4 when x is equal to 2 and x is equal to -2, and lastly it's going to be -9. So the graph will look something like that when you've applied the negative coefficient to the whole function itself. So essentially you flipped it along the x-axis. So this is y is equal to negative the function of x. Where has it been flipped? It's been flipped along the x-axis reflection line here. Alright, so that's an example of what happens if you apply a negative coefficient to the whole function. Now, that's the x-axis. What happens when you're reflecting functions in the y-axis? If you apply the negative coefficient to the variable input of a function, so y is equal to f of -x, that causes the graph of y is equal to f of x to be reflected in the y-axis this time. So if you do the negative to the variable itself, not the whole function, it's reflected in the y-axis. So essentially here, instead of the y-coordinates being negative, the x-coordinates of all the points are multiplied by -1. So you may see that the function I'm using is no longer x squared. That's because if I reflected that graph that was that curve going like that in the y-axis, it would look the same, so you won't be able to see the effect of it. So that's why I've chosen this. Given the function is to times the input by 2 and add 3 to it, so f of x is going to look like this, 2 times by x plus 3. I've graphed the graph of the function in blue below. So you might remember to linear equations when we're graphing them, that's the slope, and goes up by 2 for every 1 step across, and it's got a y-intercept of 3. Y-intercept of 3 going up by 2 every time. What would y is the function of negative x look like? Well, I've said that essentially this causes the x-coordinates of all the points to be multiplied by -1. So here the x-coordinate is 1. At this same y, for y is equal to the function of negative x, it's going to be -1. Here it's going to be -2, -3, -4, 0 is to stay 0. Here, on the blue line, it was at -1. The x-coordinate was -1. So -1 times by -1 is going to make it +1, so the x-coordinate for y is equal to the function negative x will actually be a positive one. It will be positive on this side. So you can see that's going to form a line, and I'll just draw that line. There, that is f of x, but this time it's the function of negative x. The x coordinates have all been flipped to the negative, and you can see that that has been reflected in the y-axis. If this was the line of reflection, if I put a mirror along the y-axis, you can see the line is reflected through that, so line of reflection. So hopefully that helps you out with understanding the reflection transformation of functions. It's just multiplication by a negative number, either of the variable or the function itself. That's the last transformation we need to do on functions relations, and I'll see you in the next video.